The image is almost quiet. A star that's been dimmed, disciplined, held at bay. And off to the side, small, stubborn HR 8799CE sits as a point of light that shouldn't be there, except it is. Then if you let your eyes linger, something else seems to appear. A faint suggestion of a halo. Not bright, not dramatic. Just enough to make a careful person uneasy. This is where the story begins. Not with certainty, but with a shape that tempts you to believe. We're looking at an exoplanet by direct imaging, one of the rare times we try to separate a planet's own light from the overwhelming glare of its star. HR 8799C is real. It's been seen as a directly imaged exoplanet, a world whose photons reach us without having to pass through a transit dip or a radial velocity wobble. But this particular feature, the halo, doesn't arrive with the same confidence. It arrives like a whisper, and then it does something worse. Across a months-long analysis, the halo around HR 8799C moved wrong. That phrase, moved wrong, sounds simple. It isn't. In exoplanet work, the motion of a feature can be evidence. It can also be an accusation. It forces the same question again and again, signal versus artifact. Is this the exoplanet's atmosphere leaving a trace? Or is this instrument systematic calibration, drift speckles, subtraction ghosts performing a convincing imitation? Let's make the stakes plain without exaggeration. If the halo were real, if it were truly centered on the planet and behaved like a physical structure, one plausible interpretation would point toward the exoplanet atmosphere, high clouds, haze, aerosol scattering. Not life, not a biosignature, but the kind of atmospheric texture that on other worlds can either reveal gases or hide them. One of the many reasons the search for signs of life lives and dies on interpretation. Because here's what exoplanet science learns the hard way. Detection is not the same as understanding. Atmosphere is not the same as habitability. And a visually persuasive feature is not the same as reliable evidence. So what does moved wrong mean in practice? In the simplest sense, if a feature belongs to the planet, if it is truly an atmospheric halo, then as you compare images from different times, you expect it to stay locked to the planet's position. It should remain planet-centered, or at least behave in ways you can tie back to physics and geometry. Planet-centered behavior is a kind of sanity check. The data don't just show something, they show something that stays with the exoplanet. But in direct imaging, the star is the tyrant of every pixel. You suppress it, you subtract it, you model its pattern, and what remains is never pure. Halos can arise from the optics themselves, from the point spread function, how a telescope spreads light into rings and wings. Residual speckles can sit near where the planet is supposed to be. They can masquerade as structure, and crucially, those speckles can evolve, so the motion becomes a test. A feature that shifts in a way that tracks the instrument, not the exoplanet, is not an atmospheric revelation. It's a false positive wearing a planet's mask. That's the tension at the center of this case, exoplanet atmosphere versus instrument systematics. And it's why the title's promise is not merely that a halo was seen, but that it moved wrong. This isn't a discovery story, it's a credibility story. A story about the boundary between what we know, what we infer, and what we can be fooled into believing. We can hold two facts at once without flinching. The planet is there. The halo-like structure can appear in the processed images. The danger is the third step interpretation, where the mind wants to close the loop. A halo means haze. Haze means atmosphere. Atmosphere means no, not yet. Here, the honest question is narrower and more demanding. Is the halo a stable physical signature tied to the exoplanet atmosphere? Or is it an artifact born from calibration choices and drift? An evidence moment arrives not as a number, but as a mismatch. The halo doesn't just appear, it changes. It refuses to sit still in the way a real planet-centered structure should. It moved wrong. And that wrongness is the entire reason we have to slow down. Because if you've ever watched a magician, you know the trick isn't the rabbit, it's your attention. In direct imaging, the trick isn't the exoplanet, it's the subtraction. You're asking a method to erase a star so thoroughly that you can study what's left. That method can also leave behind a faint ring, a ghost edge, an overcorrection, something that looks like an atmosphere when it's only a scar from the process. A persistent planet-centered halo could still be atmospheric scattering in principle. But the word persistent matters. The word centered matters. And the title is telling us those conditions are in doubt. So we do what this field demands. We treat the halo like a suspect, not like a trophy. We ask, does it track the planet, or does it track the instrument? Does it behave like an atmosphere or like a residual pattern? Does its movement look like time variability on the world, or like calibration drift in the machine? And already the most important confounder steps forward, plain, and named instrument systematics. Thermal stability, detector effects, the evolving restless structure of speckles that can mimic a ring where none exists. A halo that moves because the subtraction is not a still photograph of reality, but a negotiated settlement with noise. This is the quiet discipline behind exoplanet atmospheres. Before we speak about biosignatures or technosignatures, before we even dream of signs of life, we have to survive this kind of ambiguity. We have to learn the difference between faint and fragile, between seen and known. And the months-long analysis embedded in the title tells you something else. This is not a quick triumph. It's a prolonged argument with your own data. It's the slow process of trying to make the same story survive every recheck. So we end this first movement, but the mystery truly lives in the method itself. Because to judge whether the halo around HR 8799CE is an exoplanet atmosphere clue or an artifact, we have to understand how direct imaging tries again and again to turn blinding starlight into a world. The raw frame is almost insulting in its imbalance. The star dominates everything, an overexposed presence, a complex glare that spills into rings and spikes and mottled patterns. Somewhere in that glare, the exoplanet is hiding, not metaphorically, literally hiding in the star's light. And yet, in direct imaging, we choose to do something audacious. We try to subtract the star away. High contrast direct imaging works because the star's light has structure, repeatable structure, and because we can model that structure well enough to remove most of it. The exoplanet's light is still there afterward, faint and vulnerable. What remains is a residual image, part planet, part leftover starlight, part instrument. In the HER 8799C case, that residual is where the halo appears. And because the halo moved wrong across a months-long analysis, this section is not about romance. It's about how we try to know what belongs to an exoplanet atmosphere and what belongs to the machinery. Picture it as layers. First layer, the star's pattern. In the camera, even a perfect point of light doesn't stay a perfect point. Optics spread it out into a point spread function. Bright core, faint wings, ripples, and speckles. Those speckles matter. They are the enemy. They can be as bright as the planet where we're looking, and they can look like structure. Residual speckles can mimic extended features, especially near the planet's location. Second layer, the subtraction strategy. Direct imaging doesn't give you a clean planet photo by default. You earn it by modeling and removing the star's light as best you can. In practice, that means using reference patterns built from other images, other angles, other times, to predict what the star should look like in each frame, then subtract it. But subtraction is not neutral. It's a choice, and choices shape what survives. Here's the central tension pair in plain language model fit versus calibration drift. When you subtract, you can do two kinds of harm. One is obvious: you can fail to subtract enough starlight, leaving speckles that masquerade as signals. The other is more dangerous: you can subtract too aggressively and carve away real planetary light, or sculpt the leftovers into something that looks physical, like a ring and arc, a halo. So when a faint halo shows up around HR 8799c, the first question isn't, what does the exoplanet atmosphere look like? It's, could the pipeline be painting? A months-long analysis is not just time spent staring at images. It's a sequence of deliberate tests. You change the alignment slightly. You alter the reference set. You adjust how the star's pattern is modeled. You ask the same data to tell the story again under different rules. Repeating observations across time and wavelength is a reality check, but so is repeating the reduction itself. And here's the key: if the halo is real, it should survive those changes in a meaningful way. Not perfectly, not without any variation, but in a way that's consistent with physics and consistent with being planet-centered. A real atmospheric signal, especially one tied to scattering, should show a kind of coherence. It should not behave like a free-floating artifact that wanders when your calibration choices wander. This is where spectroscopy enters quietly as a second path. You don't need it to understand the method, but it explains what real might mean if the halo is physical. If a feature is due to atmospheric scattering, it can be wavelength dependent. The halo might look different in different bands. If the halo is real and wavelength dependent, its behavior should align with scattering physics and remain consistent across bands and epochs more than an artifact would. That's the ideal. But direct imaging lives in the world of the almost detected, the almost removed, the almost true. So we name the confounders without euphemism. The first is instrument systematics, the one we can't wish away. Instrument systematics can create a halothermal changes, subtle flexure detector behavior, shifts in the point spread function. The star's pattern is not frozen in time. It breathes. And when it breathes, the subtraction can leave behind features that appear to belong to the planet, simply because the planet is where we're looking hardest. The second is deeper retrieval priors and model assumptions. Even when you move from images towards spectra and atmospheric interpretation, you're still translating faint light into physical claims. That translation depends on assumptions about cloud layers, about chemistry, about what kinds of atmospheres are allowed. Clouds and hazes can flatten or mute features, creating degeneracy. Multiple different atmospheres can explain the same faint signal. So the method has two fronts of uncertainty: the image extraction and the atmospheric interpretation. The HR8799C halo case forces us to keep them separate because the title's hook halo around HR8799C moved wrong could be telling us about either front. The halo might not be atmospheric at all, or it might be atmospheric but entangled with the instrument's fingerprints. The months-long analysis exists to pry those apart. Here's an evidence moment you can feel, even without numbers. You rerun the pipeline, and the halo changes. Or you adjust calibration, and the halo shifts. That is the telltale sign of fragility. Not proof of falsehood, but proof that the feature is dependent on the method. Dependent enough that you don't get to call it the planet yet. And this, in a strange way, is where the search for signs of life becomes more serious, not less. Because biosignatures and technosignatures, if we ever claim them in an exoplanet atmosphere, will be subtle. They will live in weak signals and complicated models. A field that cannot police its own ghosts cannot be trusted with its own miracles. So this is how we know we build redundancy into the process. We try to make the results survive different calibrations. We look for planet-centered consistency. We test whether wavelength dependence makes physical sense. We treat beautiful structures as guilty until proven innocent. And we keep returning to the title thread because it is the discipline embedded in the hook the halo moved wrong. That wrongness is not a footnote. It is the reason the method must be explained at all. Now we're ready for the next step, where time stops being a background detail and becomes the interrogation light. Because once you understand how direct imaging turns glare into a world, you can finally ask what it means when that world's halo won't stay where physics says it should, when time itself makes the picture confess. The room is dim. The screen is bright. Two images sit side by side. Two moments separated by time, each one a careful attempt to pull an exoplanet out of a star's glare. HR 8799C is there in both. A small, steady point, and then your eye catches the faint, uncertain companion, the halo. In one image, it seems to cradle the planet. In the other, it has shifted subtly but enough to matter. Not drifting the way a planet-centered feature should. Not behaving like a stable atmospheric structure that's simply along for the ride. Across a months-long analysis, the halo around HR 8799C moved wrong. This is the section where the story changes shape. Because time is not just a timeline. In exoplanet work, time is a diagnostic. It can reveal weather. It can reveal bias. It can reveal what belongs to the exoplanet atmosphere and what belongs to the instrument. Here's the key question we have to answer honestly, and without forcing it. What would a real halo do over time? And what would an instrumental halo do over time? Start with the tempting explanation. If the halo is real, if it's tied to the exoplanet atmosphere, then variability is not impossible. Giant planets can have changing clouds. Haze layers can shift. Brightness can modulate. Real atmospheric phenomena can vary, and clouds can change what we see. The idea of a planet whose appearance subtly evolves is not science fiction, but variability has a signature. It doesn't just wander, it has constraints. It tends to correlate with wavelength. It tends to correlate with overall brightness changes. It tends to remain centered on the planet even as it changes shape. If the halo were planetary, we'd expect it to behave like something anchored to the planet, even if it is dynamic. Now the other explanation, the one the title keeps pushing us toward. In direct imaging, the residual patterns you fight speckles, P, S, F wings, subtraction leftovers are not fixed. They evolve as conditions change. They evolve with temperature, with pointing, with the instrument's state, with subtle calibration drift. Instrument systematics can produce apparent motion speckle patterns, evolve centering shifts, and PSF subtraction residuals can walk across the field. So when the halo moves, you ask a different question. Does it move like the planet or like the system that observes the planet? This is the core tension pair, spoken plainly planet atmosphere versus instrument systematics. And time is the judge. Imagine a simple plot, not numbers, just a line. Observation epochs along the bottom. The halo's apparent position on the side. If the halo belonged to the exoplanet, that line would stay tied to the planet's location or change in ways that keep the planet as the center of gravity. But if the halo is a residual from the star subtraction, that line can drift with the telescope's moves. It can correlate with observing conditions. It can shift when you change how the data are calibrated. It can appear to move in a way that is wrong, only because it was never truly attached to the planet in the first place. This is the change of perspective. Time does not automatically make a mystery deeper. Sometimes it makes it simpler. Sometimes it exposes the mechanism of a false positive. And the phrase, months-long analysis, matters here. Because a single night can fool you. A single reduction can fool you. But across months, you can ask whether the feature is repeatable, whether it returns under different circumstances, whether it behaves consistently across time and wavelength, whether it survives independent reprocessing. So the analysis becomes a cross-examination. You test the halo against the observing conditions. Does its motion track temperature shifts, instrument configuration changes, or other signatures of instrument systematics? If the halo's motion correlates with observing conditions, it leans toward artifact. You test it against sampling. Did you observe often enough? Did you capture the right cadence? Or are you seeing a mirage built from sparse time coverage? Time variability can be confused with sampling. Too few epochs can make random residuals look like meaningful drift. That's an evidence moment in itself, the possibility that movement is not movement at all, but an illusion created by the gaps between measurements. This is where we keep the honesty tags close. We have an exoplanet seen by direct imaging. We have a halo-like structure in processed images. We have apparent motion that does not match the clean expectation of a stable planet-centered structure. That mismatch increases suspicion of instrument systematics, and only then, carefully, we allow the speculative edge without stepping off the cliff. If the halo were genuine atmospheric scattering time, variability could hint at dynamic aerosol layers, clouds and hazes changing over time. That would matter not because HR 8799CE is a life target, but because aerosols are the great interpreters and deceivers in exoplanet atmospheres. They can hide gases, they can reshape spectra, they can complicate any future biosignature discussion on other worlds. But the title is already warning us the halo moved wrong. So our job in this section is not to rescue the halo with imagination, is to respect the diagnostic power of time. And time gives us another tension pair detection versus interpretation. Detecting a faint structure is one thing. Interpreting it as atmosphere is another. Interpreting atmosphere as meaning signs of life, technosignature context is yet another. Each step multiplies the risk of false positives unless the earlier steps are solid. So we sit with what the data are allowed to say. The halo's behavior across a months-long analysis is not clean. The motion is a warning flag. And if you're tempted to feel disappointment, consider what this discipline buys us. It buys us a standard. Because if a halo can be fooled into being, then a biosignature can be fooled into being too, unless we build a habit of asking what else could cause this. So we end this movement with the suspicion sharpened not as cynicism, but as method. The halo's wrong motion forces us toward the uncomfortable center of exoplanet atmospheres, the hall of mirrors where our tools, our models, and our hopes can reflect each other. Next, we walk into that hall deliberately, and we name every mirror we can. The halo is still there on the screen, faint as breath. But now it feels different. Not like a revelation waiting to be claimed, like a question that refuses to be owned. In this section, we stop treating the halo as a character and start treating it as a test. Because the title's promise is not that HR 8799C has a halo. The promise is that the halo around HR 8799C moved wrong, and that a months-long analysis had to decide what that wrongness meant. So we name the room we're entering a hall of mirrors. This is the limitation-heavy part of the story. Not because science is weak, but because it is disciplined. In exoplanet atmosphere work, especially in direct imaging, the most dangerous words are the ones that sound like certainty. Here's the key question. What is the most defensible interpretation right now, and what would it take to change it? We begin with the first and strongest confounder, the one the title practically points to, instrument systematics. In high-contrast direct imaging, the star is never fully gone. Its patterns linger. They change. They can create structure where none exists. Instrument systematics, PSF instability detector artifacts thermal drift, are a dominant risk. The subtraction can leave behind a ring-like residue that looks like a halo. And because the halo moved wrong, time itself has already begun to implicate the instrument. This is the tension pair, spoken plain signal versus artifact. If the halo were a stable feature of the exoplanet atmosphere, it would not be so sensitive to the system that measures it. It would not drift with the instrument's state. Yet the title tells us the halo moved wrong across a months-long analysis, which forces the conservative posture treated as suspect until proven otherwise. That's not pessimism, that's falsification. Now the second mirror in the hall, clouds and hazes degeneracy. Even if we imagine cautiously that some part of the halo is real, some scattering signature tied to the planet clouds and hazes can imitate multiple stories at once. Clouds and hazes can flatten or mute features, and multiple atmospheric scenarios can fit the same faint signal. In other words, even a real atmospheric effect can be ambiguous in meaning. This becomes another tension pair detection versus interpretation. A halo could be aerosol scattering, or it could be a residue from subtraction. And even if it is aerosol scattering is not a single thing, it's a family of possibilities. Different particle sizes, different layers, different geometries, different time variability. The exoplanet atmosphere can be real and still refuse to yield a single clean explanation. And then the third mirror, retrieval priors and model assumptions. At some point, to talk about an atmosphere, you are translating light into physics. That translation involves assumptions, the temperature profile you allow, whether you treat chemistry as equilibrium, how you represent clouds, whether you accept a simple 1D picture when the world may be 3D and dynamic. Retrieval priors and model assumptions can overfit weak signals, and when the data are fragile, the model can start to describe itself instead of the planet. This tension pair is subtle, but brutal model fit versus calibration drift. A model can fit a halo. A model can even fit a moving halo. But if the feature is born from instrument systematics, the model is fitting a ghost. And the better the model becomes at fitting ghosts, the more dangerous it gets. So we ask, what does intellectual honesty require us to say right now? From this outlines evidence and constraints. It requires a best current conclusion. Here it is stated with restraint. Given a halo that moved wrong, the most conservative interpretation is that it is not a stable planet-centered atmospheric structure. At least not yet, not by the standards we would demand before letting it shape broader exoplanet atmosphere claims. That sentence is doing exactly what it should, separating what we know from what we infer. We know HR 8799c is a directly imaged exoplanet. We know a halo-like feature can appear in processed images. We know the feature's behavior moved wrong is a mismatch that raises suspicion. We infer that instrument systematics are a likely driver, and we leave a careful door open without stepping through it. A real halo remains possible if future observations show repeatability across different wavelengths and instruments and consistent planet-centered geometry. But that possibility is conditional. It does not override the present burden of proof. It sits behind tests that haven't been satisfied within our source of truth outline. This is what the Hall of Mirrors teaches: the most compelling story is not always the most probable one. And probability is not a feeling. It's a discipline built from confounder tests. So we summarize the confounder test in the simplest terms. If the halo is dominated by instrument systematics, it will change when calibration choices change, and it will drift with observing conditions and PSF behavior. If it is real atmospheric scattering, it should show coherent, repeatable behavior across time and wavelength anchored to the planet. The title gives us the warning, moved wrong, and the months-long analysis tells us the team didn't accept the first impression. They kept pressing the feature against alternative explanations until it started to look less like atmosphere and more like the method talking back. This is the emotional center of limitation-heavy science, the courage to say not enough to claim a planetary halo as atmosphere, not enough to treat a subtle structure as physical, not enough to let a beautiful artifact become a false positive that contaminates the larger project of reading exoplanet atmospheres for signs of life. And then quietly we pivot toward meaning, because limitation is not an ending, it's a calibration. If we cannot trust subtle halos without deeper validation, what does that imply about the standards we will need for biosignatures and technosignatures? Claims that would be even more fragile, even more consequential. We take that question into the next section, where the story widens just enough to become a checkpoint what counts as a sign and what kind of uncertainty we must be willing to carry. The final image returns to the same quiet temptation, HR8799C, as a small point beside a disciplined diminished star. The halo is there, maybe. Or maybe it's the memory of what we wanted to see. The frame holds its breath either way, and we let it, because the title's promise was never comfort. It was a warning written in plain language. The halo around HR8799C moved wrong. A months-long analysis didn't turn that wrongness into a triumph. It turned it into a standard. This is the cosmic checkpoint, not a detour into philosophy, a calibration of what counts as a sign when all you have is faint light and the courage to doubt yourself. Here's the key question. What standard of evidence should we demand before we let an exoplanet atmosphere feature influence any story about signs of life? Start with what this case has already taught us. In exoplanet science, especially in direct imaging and spectroscopy, strong claims don't come from a single persuasive image. They come from converging evidence, repeatability, and explicit tests against false positives. And the halo case is an example of why a visually compelling feature can be born from instrument systematics, shaped by calibration, drift, and still look like a physical structure. So the first rule at this checkpoint is simple. The method must be more reliable than the meaning we want from it. That's not cynicism, it's respect for uncertainty. Because if a halo can be fooled into being, if it can move wrong in a way that implicates the instrument, then any future biosignature claim could be fooled into being as well, unless we harden our standards now. The halo is not a sign of life, but it is a rehearsal for the kind of caution life detection will require. This is the tension pair that defines the checkpoint biosignature claim versus false positives. A biosignature, if we ever find one, would likely appear as chemistry inferred from light patterns and spectra differences across wavelength hints of gases in an exoplanet atmosphere. A technosignature, if we ever treat it seriously, would have to be tied to observational channels. We can measure atmospheric industrial gases, unusual reflectance anomalies that survive calibration and independent checks. And unless the outline tells us otherwise, those remain plausible, unconfirmed, and burdened by alternatives. So how do we avoid fooling ourselves? We demand the kinds of cross-checks this halo struggled to satisfy. We demand repeatability across time, because time can betray the picture. We demand coherence across wavelength because physics should rhyme even when the data are faint. We demand independent replication because a single pipeline can create its own consistent illusions, and we keep saying the words that guard the boundary false positive. Instrument systematics, model assumptions, retrieval. The discipline is not just extracting an exoplanet signal, it's proving that the signal is not an artifact. The HR 8799CE Halo case argues for stricter standards when interpreting subtle spatial features in direct imaging as atmosphere evidence, because those features can drift with the instrument and masquerade as planet-centered structure, and then only then we allow a cautious speculation about why this matters beyond one world. As instruments and analysis mature, direct imaging paired with spectroscopy could one day constrain aerosols, clouds, and hazes well enough to reduce ambiguity in interpreting gases on smaller, cooler exoplanets. Not by erasing uncertainty, but by mapping it, showing which features are stable, which are fragile, which are method dependent. But we do not pretend that future capability changes present truth. The halo moved wrong. The best current conclusion remains provisional. That's the point. Now we name the unknown we're willing to carry forward because the checkpoint isn't just be careful, it's be measurable. Here is the named unknown stated plainly and tied to the case. Is the apparent halo driven by wavelength-dependent PSF and speckle behavior instrument systematics and calibration drift, or by real cloud and haze scattering in the exoplanet atmosphere? That question is not poetic. It's measurable. It tells you what future data would have to do, show the halo repeating across multiple bands, across multiple epochs, ideally across independent instruments, with planet-centered geometry that doesn't wander when the method is perturbed. Until then, the halo is not a message from HR 8799C's atmosphere. It's a lesson about our own vulnerability, about how the search for signs of life can be derailed by the smallest unacknowledged confounder. And in a quiet way, that lesson is its own kind of awe, because it means the universe is not obligated to be clear. It means we have to earn clarity. It means the path to life detection begins not with celebration, but with restraint, learning to recognize when the instrument is speaking in the planet's voice. The last image holds the exoplanet as a point of light, the halo as a question mark that may or may not belong. In the faintest light, the test is not only what we can see, it's what we can refuse to claim until the data stop moving wrong.